In this example, we have a box being pushed across the floor. The mass of the box is 2.2 kilograms, and the velocity is 2.1 meters per second, and it is constant. The force with which the box is being pushed is 15 newtons, and the question is, what's the coefficient of kinetic friction between the box and the floor? Well, as is the case with all of these problems, we have to look at the forces involved. I've drawn them out for you on the diagram there. The motor's pushing with a force of 15 newtons, and it's pushing to the left. Friction, little f, opposes that motion, so it's pushing to the right. The weight of the box, W, pulls down, and in response to that, the floor pushes back up with a normal force, Fn. Alright, since everything's happening in the horizontal dimension, let's concentrate on that. There are two forces. The force that the box is being pushed with, capital F, and friction. They oppose one another, so the sum of those two forces is little f minus capital F. I'm defining motion to the right as positive, so little f is positive and capital F is negative. And the sum of those forces has to equal mass times acceleration. Now, we don't know what little f is yet, but we do know what capital F is, 15 newtons. We also know the mass, 2.2 kilograms. But what's acceleration? Actually, you're given the acceleration, but you're given it in a disguised form. Look at the velocity. The velocity is 2.1 meters per second, and it's constant. If the velocity is constant, what does that tell you about the acceleration? A constant velocity is not changing. Acceleration is the change in velocity. So a constant velocity means that acceleration is 0. So we'll put in 0 for acceleration. Now what do we have? F minus 15 newtons equals 0. So the frictional force is 15 newtons. Now this number ought to make perfect sense to you. If the box is moving at a constant velocity, then the acceleration must be 0. So the sum of the forces has to be 0. If the applied force is 15 newtons to the left, then friction must be perfectly counteracting that, so the sum of the forces is 0. So friction has to be 15 newtons to the right. Of course, the question didn't ask us about friction, it asked us about the coefficient of kinetic friction. So we have to figure that out. Well, we know how friction relates to the coefficient. Friction equals mu k times the normal force, Fn. But what's the normal force? Well, to figure out the normal force, we're going to have to look in the vertical dimension. Weight pulls down on the box, and the floor keeps the box from accelerating downwards by pushing up with the normal force. In order for that to happen then, the normal force must perfectly counteract the weight, so the magnitude of the normal force has to be the same as the magnitude of the weight. So we could also say that the friction is mu k times the weight, since weight and normal force have the same magnitude. Well, we know what weight is. Weight is m times g. So really friction is mu k times m times g. Well, we know what little f is. That's 15 newtons. We don't know mu k, but we do know m, 2.2 kilograms, and we know g, 9.8 meters per second squared. To solve for mu k, I just have to divide both sides by 2.2 kilograms and 9.8 meters per second squared. Since a newton is a kilogram meter per second squared, the newtons on top cancel with the kilogram meter per second squared on bottom, so we get no units. That's good because mu k shouldn't have any units, and when we work out the numbers, we get 0.68. So the coefficient of kinetic friction is 0.68.